Hello everybody, Mr. Guiton here, and today we are going to learn how to solve missing sides of a right triangle using sine, cosine, and tangent. I have 3 examples on the whiteboard and we're going to work through them together, and hopefully as I demonstrate you will understand what I'm doing and you will learn how to do it on your own. So, here is our right angle. I forgot to mark that. Okay, so on our first example, we are given an angle. We are told that it is 25 degrees, and we are trying to find this letter A, and it's in meters. And we have the hypotenuse is given to us. It is a 2, and I am solving for A. So, what we are going to do is we are going to use this angle and sine, cosine, or tangent, and we're going to create a fraction, we're going to create a ratio, and we're going to use the number that we get for the sine, cosine, or tangent, and it will all balance out. I will show you how to do it using a calculator or using the trig chart that I have given to you all. So, let's lay out what we know so far. If we're using this angle, we have the hypotenuse given to us, and based on SOHCAHTOA, I know that I'm not using the tangent because we need the hypotenuse, so it's either the sine or the cosine. And since it is this angle, we are looking at the opposite side. So the opposite side is missing, and that means we are looking with the O and the H. So we are looking at sine. And here is how we do this. We say that the sine of 25 degrees is equal to the opposite, which for now we're just going to leave as A, equals A over the hypotenuse, which is 2. Well, we can use our calculators or we can use our trig charts, and what we discover is that the sine of 25 is just a decimal, and we can use it as just a regular number. If I want to use my trig chart, I will use my trigonometry table. I will go down to angle 25, and I will see that the sine is given to us as 0.423. 0.423 given the trig table. We can use this number. We can say that 0.423 is equal to this right here. We haven't changed that yet, so it's equal to A divided by 2. But if I want to get A by itself, if my goal is A by itself, let's see, what can I do to get rid of that divided by 2? I will do the opposite operation. So we have divided by 2. I can multiply the right-hand side by 2. But if I do that, I also have to multiply the left-hand side by 2. And I will get A all by itself. I will have A is equal to 0.423 times 2. So I'm just going to multiply each thing by 2. We get 8, 4, 6. So if we want to do it by hand, this is the number we get. Or let's see if the camera will see my calculator on my phone. Okay, so here's my calculator on my phone. If I want to do this, I can just say 2 times the sine of 25 degrees. And this will give us almost almost the same answer, but when we use the calculator, it gives us a more precise number for the sine of 25. It tells us 2 times the sine of 25 is 0.845. So when we use the calculator, we get 0.845 as A. But to be honest, I would probably have you round this to 2 decimal places. So I would want the answer to be 0.85 meters. So either way, this would round to 0.85 meters. That's how we solve the first one. When you look at it like this, and you come to find out you just multiply both sides by 2, 2 times the sine of 25 is A, you realize, oh, okay, this looks crazy because I've got like a word mixed in with my equation, but just understand that the sine of 25 is just a number. It's a decimal, and we can get it down to 3 decimal places or more, but it's just a number that we can work with. So let's move on to the next one. I have B as my variable, and I have 60 degrees here, and I have 9 meters. So I want to find the number of meters up here. Well, let's look. I have the hypotenuse. 9 is the hypotenuse, so I know that I'm not working with tangent. Again, I'm working with sine or cosine. Well, since I'm working with 60 degrees, I know that this is the adjacent side. It is touching the angle, so it is not the opposite side. It is the adjacent side, which means I'm working with the cosine. So I can write down cosine of 60 degrees is equal to, well, the cosine goes with adjacent over hypotenuse. So the adjacent, we don't know what it is, it's just B for now. So the cosine of 60 degrees is B over 9. Okay, and if I want to get B all by itself, I will multiply 9 to both sides. So I can just say 9 times the cosine of 60 degrees is equal to B. So I will do it on my calculator, as this is simply faster than showing you the trig chart over and over. So I have 9 times the cosine of 60 degrees. And that will give us 4.5. 4.5 meters. 4.5 meters. B equals 4.5. Because I just multiplied 9 times the cosine of 60. Okay. So for our last one, I'm not sure if this is pointing at it. Okay. So for our last one, we're trying to solve for F, side F. I see that I do not have the hypotenuse given to me, so I know that tangent is going to be the ratio that I want to use. And we've got 28 degrees is what we are working with, so I'm just going to start by writing the tangent of 28 degrees. Tangent of 28 degrees is equal to the O, the opposite, over the A, the adjacent. So we want the opposite side over the adjacent side. So the opposite side is F, and the adjacent side is 18. All right. Well, just like the other two that we've had so far, our A was on top, our 2 was on bottom, our B was on top, our 9 was on bottom. Our f is on top, our 18 is on bottom. We'll do the same exact thing. We will multiply 18 to both sides in order to get f all by itself. So if I have 18 times the tangent of 28 degrees is equal to f, I will just use the calculator on my phone. I do have the answers all prepared already, but I want to show you how to do it. We will just say 18 tangent of 28 degrees. Okay, and it tells us that our number is 9.57. I'm going to round that to 2 decimal places. 9.57. F equals 9.57. This one is in centimeters. Okay. And we know that this is true because if this is 28 degrees, and this is 90 degrees, we know that this other one will be 62 degrees. Now, the bigger angle will be opposite from the bigger side, and the smaller angle will be opposite from the smaller side. So, if our f is about half as much as 18, then we know that we're pretty much in the right ballpark. We can look at our numbers and we can know that we didn't really make a big mistake. If it's about half the size, that is right about true. So, that is an example using sine. That's an example using cosine, and an example using tangent. Now, sometimes your variable will be on bottom, in which case you will multiply both sides by the variable, and then you will divide both sides by the cosine, or divide both sides by the tangent. So we use algebraic manipulation in whichever way we need to get the variable by itself, and then the integers and the numbers that we can work with by themselves on the other side. So I hope that this was informational. I hope that you now have a firm grasp on how we need to use sine, cosine, and tangent in order to solve for missing sides of a right triangle. Thank you very much.